Okay. Good morning. Today topic from CCNA DHCP. DHCP. Dynamic Host Configuration Protocol. The DHCP is used to provide IP address automatically to the client. So let's say you have hundreds of computers connected to one switch. Okay. All these computers need IP address to communicate. So basically, when you connect a computer in the network, your port in the switch should be one of the VLAN, maybe a default VLAN, VLAN 1, or you can make them under one specific VLAN, example VLAN, let's say 100. Now, it could be in a different floor, different room. So to go by manually to assign an IP is a big task. So what is a preferable option? Enable DHCP server in any one of the device. Which are those devices? Let's say example, you can enable DHCP in router, in switch, or in Windows server. A minimum examples. Let's say I have a switch here. Okay. I'm enabling or configuring a DHCP in the switch. So let's say here we can consider DHCP server who are providing IP address. Then you have DHCP client, which means who are accepting IP address. In our case, DHCP server is switch because we configuring DHCP services in the switch. So when a computer is connected into the network, the first task of the computer who is here for us as a client, this will check the DHCP, it will check the IP address in the network. Where can I get the IP, which is called DHCP discover. DHCP discover. This DHCP discover will send to, let's say this computer is checking an IP the moment it connected to the network. It will send the DHCP request to the entire, to this port, and this port will send to the respective VLAN 100 to everyone like this and like this. And also this will be sent to the respective gateway of this network. So if the DHCP server is available, then the DHCP server, once receive the discovery message, this will respond back with DHCP offer. It's very simple. A client is sending discovery message to see is there any DHCP server in the network to get the IP. If the DHCP server is available, a server will send response back to the client with the DHCP offer message. The offer message contains the free available IP from the DHCP server. Once the client has received offer and came to know that there is a free IP, it will send back with a request. DHCP request. The request is nothing but the offered IP address is I needed. A DHCP server is offering an IP to the respective client. Once the offer is received by the client is sending back to the server with the request, say, kindly release those offered IP. Then a DHCP server will send back DHCP acknowledgement. The acknowledgement which contain the offered IP, and the IP will be taken to the client. So there is a 4 process to identify a complete DHCP services. So when a DHCP client system sending a request to the DHCP server, they are using a protocol called UDP. So DHCP is an application layer protocol, and the UDP is a transport layer protocol. So any application layer communication, when come to a transport layer, it will add either UDP or TCP. DHCP is taking a support of UDP with the port number 68. This is for the client, and 67 for the server. So any request sending from DHCP client to the server with the UDP port number 68 and reverse is 67. Okay, it's very simple. Let's say I am a DHCP server and I have a bunch of IP configured. You guys are DHCP client, so you need an IP. So the moment you plugged into the network, your first requirement to send to know, is there any DHCP server in the network to get an IP? So you send the discovery message to me. If I am available as a DHCP server in the network, I'll take the discovery message. I'll check, is there any free IP for me? I mean, within my server. So if there is a free IP within the server, I will offer you with that IP. Like example 192.168. Let's say here, this is one of the computer. So I'm gonna offer an IP 192.168, let's say 100.11. This is what I have in my DHCP database. I'll send as an offer. Then the client is confirming for the request to get this IP. Then the server will be acknowledged, yes, this IP belongs to you. So then the client is getting an IP. This is usually happened a process. In two cases, a client, when a sender request, the client will not get an IP for two reasons. One, there is no DHCP server in the network. No DHCP server in the network. If there is no DHCP server in the network, a DHCP client automatically will select one IP, which is called 169.254.XX. In this range, a client automatically select IP by themselves, which is called APIPA, Automatic Private IP Address. Automatic Private IP Address, APIPA. Let's say in second scenario, DHCP server is already there and the discovery message is accepted by the server. But when server look into its database, there is no free IP. The IP is already consumed by the X peoples. Let's say I've configured for 100 people or 100 users, 100 IP. Okay, already 100 systems are utilizing these 100 IP. So the person who coming now is 101, the next person. So there is no free IP in the server. Then also it will go automatically to APIPA. This is all about a concept of the DHCP. So when a client sending a request to a DHCP server to get the IP in your network, somewhere the DHCP server is mandatory. A DHCP server, it could be your router, your controller, your switch, your Windows server, anything. There's a set of command to enable in your system or in your switch or router to configure the DHCP. Okay, this is a small base idea. So let's talk about the real scenario. Okay, we have one main switch. The main switch is always, we call it as a CSW. What is CSW? Core switch. Core CSW switch, core switch. Okay. which is located in the ground floor. The core switch located place is called MDF. Then we have few users in first floor. Few users in second floor. Okay, so I connected one switch in first floor and one switch in second floor. When you have a two switch in two floor, basically a switch must be connected to the core switch. This switch we call it as, let's say, ASW. What is ASW? Access switch. Access switch. Access switch is nothing but connecting your computers, phone, camera, access point, and so on. The core switch is always connected to your other switches. So I'm going to give a connection from here to here, and let's say here to here. This is this switch specific model have downlink port F01. So here we have a port called F01, fast Ethernet 1, fast Ethernet in the sense 100 MB connected to your one computer. F02 connected to another computer. Okay, same way you have two more computer connected to port number 11, port number 12. Here also you have two computer connected to port number 11, port number 12, and two computer connected to port number 1 and 2. These ports are 100 MB, which means fast Ethernet. And you have a uplink. Uplink is nothing but connecting to your core switch or switch to switch communication. So this is example G01. G in the sense 1000 Mbps. So this is G01 and the second link G02. This switch has 2000 MB cable, a port. This is G01. Okay. Now let's say this has become under VLAN 101. These two ports are become under VLAN 101. So the range is called 192.168.101.0 and gateway is 10.1. Gateway to reach to the another network. Same here as well. 192.168.101.0. So basically these computer can communicate to via this port, coming to this port, coming to this port, and coming down and going to this port. They can communicate. Why they can communicate? Because these two computers are in the same network, even though they are in different switch. This is belongs to second floor and this is belongs to first floor, but they are in the same network. Hope you understand. Same way, these two computers, let's say this is in VLAN 100. This is in VLAN 100. Okay. The network we planning to give 192.168.100.0. Same way, 100.1 is the gateway. Here also same. 100.1 is the gateway. So basically, these computer will go out to this cable, going to this cable and coming down to this computer. They can communicate each other, or even this computer to this computer can communicate each other. Why? Because even they are in the same VLAN 100, even though they are in different switch. Hope you understand. This has been discussed already. Now, The other challenge, you have a VLAN 100 computer and you have a computer in VLAN 101 in different network. They wanted to communicate each other. To do a different VLAN communication, you must need a layer 3 switch, routing capacity switch, which is we generally called core switch. So this is our layer 3 switch. Okay. Now, a switch is just a layer 3. To get those services, we have to enable layer 3 functionality. So what do we need to do? We already created VLAN 100 in and 101 in both of the access switches. So let's see, go to the core switch. Okay. VLAN 100 name. What is the name of the VLAN? So we're planning to give here data 1. Again, VLAN 101 name data 2. So we created two different VLAN. Okay. Already this port is called a trunk port. Switch to switch port is called trunk port to allow all the VLANs or the required VLANs. To communicate between different network, we wanted to enable the routing in the core switch. So, so the first task is to create the VLAN, and second task, assign IP address to the VLAN interface, which is your gateway IP. Let's for VLAN 100, the gateway IP is 100.1. So we go to the core switch interface, VLAN 100. Okay. Then IP address 192.168.100.1, 100.1, 255.255.255.0. Same way, interface VLAN 101. Same IP address. So once you configure the IP in the core switch, you have to enable the command called IP routing. Okay. So by doing a VLAN configuration and interface VLAN configuration plus enabling IP routing in your core switch, your different network will be communicate each other. Okay. So I'm talking about the same lab which we are going to test it. Now our final task. What is our final task? To enable the DHCP. So let's say if you configure the DHCP here in your core switch, okay, the VLAN 100 computer, when they need IP, I'm giving auto IP in this PC. So the moment I'm giving auto IP in this computer, it will try communicating to all the other ports within the network plus to the gateway. What is the gateway? 100.1. Where is my 100.1? It's located in the core switch. So the DHCP discovery request from the PC, it will go to all the port, including your gateway. When the gateway, which is configured in the core switch, received the request from the DHCP client, it will look into the core switch database. So we already configured the DHCP in the core switch, so it will release the IP. So general ആയിട്ടൊന്ന് പറഞ്ഞുതരാം. ഒരു DHCP ഒരു കമ്പ്യൂട്ടർ ഓട്ടോമാറ്റിക് IP കൊടുക്കുമ്പോൾ അതിന്റെ ആദ്യത്തെ ജോലി IP എവിടെയെങ്കിലും ഉണ്ടോ എന്ന് തിരയലാണ്. IP എവിടെ ഉണ്ടാവുക? DHCP സെർവറിൽ. ആരാ DHCP സെർവർ? അത് ആരുമാവാം. സ്വിച്ച് ആവാം, റൗട്ടർ ആവാം, അല്ലെങ്കിൽ വിൻഡോസിന്റെ സെർവർ ആവാം, അല്ലെങ്കിൽ ഏതെങ്കിലും കൺട്രോളർ ആവാം, വിർച്വൽ VMware മെഷീൻ ആവാം. നമ്മുടെ ഡിസൈൻ പ്രകാരം നമ്മൾ DHCP സെർവർ എന്ന് ഉദ്ദേശിക്കുന്നത് നമ്മൾ ഈ കോർ സ്വിച്ച് ആണ്. ഓക്കെ. അപ്പം PCയുടെ റിക്വസ്റ്റ് ആ VLANിലെ എല്ലാ പോർട്ടിലേക്കും അതിന്റെ ഗേറ്റ്വേയിലേക്കും വരും. ഗേറ്റ്വേയിലേക്ക് വരുമ്പം നമ്മളിവിടെ DHCP ഇട്ടത് കൊണ്ട് ഇത് നേരെ ഇതിന്റെ കോർ സ്വിച്ചിലേക്ക് കയറി വരും. കോർ സ്വിച്ചിന്റെ DHCP ഡാറ്റാബേസ് നോക്കിയിട്ടാണ് IP എടുക്കുക. Okay, so I will show you the DHCP configuration. Let me share the configuration screen. Okay, you can see the yeah.
One doubt. By default, core switch will be having this DHCP, or we have to enable it?
No. We have to configure it.
Okay.
Currently, a DHCP, currently there is nowhere in DHCP server now. We are planning to make core switch as a DHCP server. We can make a core switch, we can make any other switches, or we can make a router, we can make a Windows server OS. What are the server OS? 2003, 2012, 2016, 2022, any Windows server OS, or in the virtual machines. Now, to make a core switch as a DHCP server, this is the configuration parameters. You can see here, you have a VLAN 100 client. So I'm making a layer 3 gateway IP. So a client, a VLAN 100 client trying to reach the DHCP server. The client has a gateway. So we are defining a gateway here in the core switch. This is the 100 VLAN gateway. This is 10 VLAN gateway. Description, you can put anything. If you have multiple VLAN, you have to put the gateway IP for each VLAN. Like we have only two here, so that we created only two. Basically, in real scenario, you can see BMS, CCTV, indoor camera, outdoor camera, storage, server, access point, access control system, many services. Every services should require a layer 3 interface in the core switch. Here we gave a test called data1 and data2. Now, this is the command. So IP DHCP pool is the command, and data1 VLAN 100 is the name that we are giving for us to identify. So by looking into this, what we can identify, this DHCP for your VLAN 100, and second pool for your VLAN 101. Okay, so this is just the pool name. Under the pool name, we are defining a network. When a client is trying to get the IP, what range the client should get it. That's the reason I've mentioned 192.168.100.0 and the subnet mask. And what gateway IP the client has to take, that is called default router. It's a gateway command. And 100.1 is our core switch IP. I mean the gateway IP for that client. And these two are optional. It's not much mandatory. But in real scenario, we're gonna give a DNS server IP. Some company have their own DNS server IP that they're gonna give. If not, for testing purpose, this is the public DNS 8.8.8.8. The domain name is the company name. Like a person name at in your email ID, there is a name at the right, the company name. So the company name is called your domain name. Same way we have created for 101. 101.1 is the gateway. Okay. Then here you can see two statement. What does that mean? That excluded IP address. I mean, we reserving some IP address for the future purpose. Like if you have any server which you should give by manual IP, shouldn't take from the DHCP, so that we received. Always there's a default concept like 1 to 10 we reserve. So the IP starting from 11 is the IP for the client. Or if you give here till 100, 101 is the available IP in the pool. So you need to know how many IP that you need to reserve. What is the purpose of reserve? To assign IP statically to any server. If you plan that in this VLAN 100, you gonna get the servers later on. Maybe you have a 5 server, one server, one IP. So you need a 5 IP reserved. So here I reserved 10 IP, and one is already used, which is your gateway. Okay. So once you've done this configuration, you need to enable service DHCP as a command to enable the DHCP. Understand? So let's say we can copy paste this. Right click, copy. Then we go into the core switch. Let's say I'm gonna take. So this is my design. Okay, what the design says, you have first floor IDF switch and you have a two different network. Okay, and you have ground floor, so second floor switch. This is your second floor switch, and you have a two different VLAN. With each VLAN has two IPs, two PCs. Okay, And two access switches, which are in first floor and second floor, are connected to your central switch, which is called your core switch. That's why I mentioned CSW, core switch. Okay. So your layer 3 interface and routing is belongs to your core switch, and we're planning to make a DHCP server as your core switch. So we'll go click a core switch. Let me share again. So this is your core switch. Maximize the screen. There is a screen. Maximize the screen. Enter. Hope you can see that. Enable config T. We'll put the paste or right click paste. The domain name is not working in this. Okay, fine. So now we can see that you reserved a set of IP in each network, created VLAN 100 pool and 101 pool, and you define the respective parameters, network, gateway, and DNS. The domain name is command is not working in the software. To see this, you go exit, show IP DHCP pool is the command. Show IP DHCP. Okay, binding is the command to see any IP address is taken or not. There you can see there is no IP has been collected. So we go back to network, and let's say this computer PC2, which is we can go for 100 first. This PC 100.2, which is a static IP. You click PC0, click PC0 desktop, IP config. Now it's a static IP. You make it DHCP. Let's see what's going to happen. So you can see the moment you put the DHCP, it took 11 IP. Whatever the command you gave, it has been reflected here. We go back to the switch to see the IP details. Let's say this is your switch. Earlier, when you try binding, you cannot see anything. Now let's say we go for binding. You can see that one IP has been taken. OCA1 is the MAC of that PC. Okay, so basically when you procure a new computer or any new devices, it's by default is automatic. So you do not need to go each computer to make it auto. You just need to configure the DHCP in somewhere like in the core switch or in the router, wherever we planned, and just to connect the computer. If the right VLAN, there is a gateway IP in the core switch, it will automatically take the IP address. No need to take care anything unless is there any real troubleshooting. But you need to know if you have 100 computers, you must need to reserve 100 IPs. Here in our cases, what we have defined, this is 255, 255, 2550. So you have a 254 IP. Only 10 IP you reserved, 1 to 10. So you will have nearly 240 IP free in this network. Any doubt? We'll make one other network. Let's say here, PC6, 101 VLAN. Desktop IP config. We can get the other IP. Okay. Let's you can ping to 192.168, 100.11. 100.11 is the VLAN 100 IP. Yes, it's reachable. You go back to the switch. Hope you can see the switch screen. You can see now two free IP. 100.11 to 101.11, they are communicating because we enable the routing also in the switch. Show run. You can see the command IP routing is already given, and you can see the DHCP. Clear? Any doubt?
The gateway we have to enable in the access
Core
switch
switch.
side or
No. Only in
core
the core
switch?
switch. Only in the core switch.
Core switch. Oh, okay, it's the same which we did above.
Yeah,
Or
you can see here. only in the core switch.
Ah, okay, okay. Ah, yeah.